think we're gonna get to work today. We're actually gonna do work. Actually do things. Maybe. We'll see what we can do. Hello. So, today is Monday, the 5th of May. And what we do at the end of all of our sprints, basically, is we do a sprint retrospective. So basically what we do is we write down, I wanted to maybe show this for people who might be curious. But basically what we do is we write down what happened during the week, and we try to make sense of all the basic things. And what we write down are basically the work estimated, the work completed, the average velocity. We estimate everything in terms of points. So basically what we do is we look at how much we actually got done, and then how much we estimated. And estimated was is basically we throw a certain amount of work on our plate each week, and then what we do is we see how much we get done, and we throw. It's sometimes important to track like how much work you throw on your plate to like kind of think about. You know, like, okay, we need to do all this stuff next. So we try to track not only the work that we're kind of thinking about, but the work that we actually got done, and see if kind of the work, like if we throw a whole bunch of stuff onto like our week that we can do, and maybe we throw too much on there and we get, you know, intimidated by the amount of work, or get paralyzed in actually doing things. So this is just going to be 13 divided by 7, so our average velocity was 1.85. And then we gotta figure out what we did right and what we did wrong. So let's see. And then I've got basically like my notes from the last week. I keep a work journal of everything I do, so I can go refer to it. So it looks like, yeah, the test level was a good decision. That really helped us out. So what else helped us out? It looks like we finally got movement working for lots of situations. Raycasts now working properly. Yeah, I was really drained this week too. So I like randomly super tired in the middle of the week. That's something that went wrong. Now, is this because of streaming? Probably is. Let's see, another thing that went pretty wrong is yesterday Perforce was having a bunch of dropped connections. I had to rebuild our Jenkins box due to updates and plugins. So I'll just throw that in there. Had to rebuild Jenkins. And we kind of just try to write down everything we can about what we were doing, and then you see if there's anything that maybe you could have done better. And we do this every week, so we can kind of trace problems back to when they started. I've got my old one. It's what went wrong. There was like a lot of rigging stuff that was a real pain in the butt. Last week the website was causing a lot of problems. We had to do a lot of little things like the big migration. So that's actually something that went right. The new websites have been holding together this week. Much less overhead than previous weeks. And yeah, what went wrong last time was Unreal 4 had a lot of bugs with the ray casting stuff that we had to look at, and we're not having to deal with that too much now, so that went alright. And what can we improve? What went wrong is like still haven't mowed the lawn, so I'm gonna tackle home chores more actively. So it's kind of an issue because I'm a self-employed, right? One of the things I also like to keep track of is that I'm not just neglecting, my actual physical life to do work, which is a bit of a problem sometimes. Surprisingly, you can get lost in what you're doing, and I am totally lost in what I'm doing. Looks like Adam and I are also a little bit off schedule. Our schedules really haven't aligned. Like, usually on the weekends, it'll roll around where I'm kind of awake for some of his streams and we can kind of collaborate a bit. But he's been super swamped with Bob's Burgers work, and that's been kind of a problem. I don't think we've been able to have like a real call since Monday. So maybe I need to talk to Adam about what's up with all the work and try better to be available for communications. So that's something I can do. Because we had a few emails, but we're never able to like really follow up with them too much. So anybody who's watched his streams and heard him complain about me is probably a little bit more up to date on what's been going on. So that's kind of what we do each week, is we write these down. I probably need to write a tech blog post this week too. I'll throw that on for the planning. Kind of want to try to do one of those every week. And then what we do is we clone our schedule. We look at our long-term stuff. So kind of what we also then do is we go over what we've gotten done and all that stuff. So yeah, I still need to read over this story. Yeah, so we need those multiple dynamic objects, we need the logic controllers and the movement plane anims, we need to rig up some of those obstacles. Yeah, that's stuff we need to do. So we'll do that. Let me kind of look at, we want to get our dates right. We want to have like our prototype stuff done the end of the week. Let me just double check that real quick. No, that is incorrect. So we've got this week and next week is kind of, and then we want our basic game prototype put together. So that's really just the core, just little things. So what's we got on the backlog here? And I'm kind of switching between some things I don't want everybody to see and all that, so. Yeah, it looks like the big one that we're going to be working on is going to be the multiple camera composition. Cameras in scene, then explore multiple cameras, explore 3D background camera work. So I'm not really sure how long that'll take for multiple cameras and all that work, but we'll mess around with it and see what we can do. And we'll probably spend a decent amount of time on that. So I usually estimate things in terms of just points. And the points are a little arbitrary. Just like, that sounds like a 2. Things like that. So we got 13 done last week, but we put 25 on, so we're going to find a few more things to do. Well, a couple things we could do. We could experiment with some water, but I think basically what I want to do is, I think we need to get animations playing properly with our, I mean, movement controller plays animations, yes, but I think basically we need to split that off into like movement controller plays animations. Then we need like bitey main character anims playing properly. And that's going to be like a 5. That's going to take a while because there's a lot of animations and a lot of states that we want. So sounds about right. So that's kind of how we do sprint planning. And I'll send stuff over to Adam. Actually, I'll just go ahead and write that email up. Let's see, sprint 18 is finished. So good. Basically, we've sent our email over there to Adam to tell him what we're up to, and we've got our basic planning going on, so we can get back to actually doing some work here today. So let's do exactly that. Let me just rejigger all the things real quick. Alright, that's looking good. So we're gonna get back to actually doing work. And last we left off, we had a whole bunch of fat sacks running around, so let's go make sure they're still running around as they should. Still have some pretty annoying issues with Perforce servers. I guess having problems of some sort, or I'm just having problems connecting to it, but we've been having a bunch of connection drops. So, let's boot up Visual Studio, and of course Visual Studio is going to immediately lock up on us. Which is always fun times for everyone. So what do we got to do today? Well, we're going to need to figure out... Well, one of the big things I discovered was that the paper sprite stuff that we were depending upon for converting texture space into world space are editor only functions, so like our nightly build went and failed on us. So we're gonna have to fix that. We shouldn't be using editor only code because, you know, the game needs to run standalone as well as in the editor. So the first thing we're going to do today is fix that. And what we're going to do to fix that is, I think we're going to cache some of that information. Basically, we needed texture space stuff working properly. Let's take a look at fat sacks jumping around. This is where we were last time. Basically just a whole bunch of fat sacks running around. And the other thing we're going to do today is we're going to fix it so these guys don't get stuck, because right now they're getting stuck inside of each other and all that sort of fun stuff, and we're going to need to have that fixed. So I think basically what we got is we need to go to our imports. Edit these. I think it's also the movement object.cpp. Yeah, so we were computing this offset and then rotating by, yeah, we've got our position object, for texture space to world space for these guys. So we need to actually calculate this position, it looks like. Collision object size. So we need the... So we need two values on our collision objects. So we're going to have to go at them. I usually just check out a whole bunch of files in Perforce and then I later go revert all the unchanged ones. Things like that. So we've got our position and we're basically setting it here. We're doing rebuild collision data. So I think what we need to do is we need two things. We need world position and we're gonna need it looks like the extent max. Let's just call it extents, world extents. So how we should be calculating that, it looks like, is we should be calculating it like this. So if we're doing it for these guys, we're basically saying collision object world position is going to be equal to sprite convert our and our world extents are going to be, we're going to convert it again here. Convert texture to world space of the collision object position. Collision object set there. We need to do that for both circles and for boxes. So what that should do is basically this import tool only runs in the editor, because obviously that's the only place we're adding these things. And if we cache them, basically what we should be able to do is just reference them over here in our movement object, instead of computing them every single time. So we're just doing collision object, world position, and world extents. So that should do it. So let's verify everything is actually as it should be. Let's see, it looks like sprites. Sprites should be fine. So let's just rebuild all the code, because that's what we do. I think I've got a few of these things written down here. Alright, so we need to... Did I mess this up? Alright, yeah, so these two actually need to be F vectors, not F vector 2Ds, because they go from 2D space to 3D space, which is important. And this will be less expensive than what we were doing, where we're calculating this every frame at runtime, pretty much. Why are you so angry? Did I change the wrong things? Yeah, looks like I did. This is what I should have changed. Yeah, I'm still just waking up, so I'm gonna make little stupid mistakes and all that stuff. That's just how we roll around here. We're gonna have to go re-import FatSack too to get all these things set up properly. Well, then we just will have to do that. And what exactly is the code that tests this out? This is the can play animation code. So we'll be taking a look where we hooked it up so that the B button would play one of the animations, which actually increases the size of the bounding box. Which is probably exactly what's happening with some of this stuff. Where we're getting stuck. Alright, well we're also gonna throw a breakpoint in here so we can take a look at all the values for these things when we actually get them set up properly. So first things first, let's re-import FatSack, and let's also throw a let's double check that we're getting the correct stuff inside of our sprite. So all we have to do is import FatSack. Let's see, his world extents are negative, 145, negative 75, and the world position, yeah, so these look correct. So I'm satisfied with that. So we'll save our FatSack re-imported with all the new data. And we're going to exit the editor and go resolve that directory. This is content characters, FatSack. Reconcile. Alright, we got that in there. So now let's go boot up the game and see exactly what we can do with the B button. Make sure we're actually doing that properly. So these numbers look proper, and what is it going to say? So the position plus the position offset. Well, I don't like that our X is not 0. Yeah, we're gonna have to trace this out. So what we're gonna have to do actually is delete all the FatSack so I can get a little bit of peace here. So sorry, FatSacks. You're gone. like it's all sorts of screwed up. What's it having trouble with? Yeah, so it's just being a real pain in the butt. That's all. So what we want to do is, if we run this, we're actually going to need to zoom in so we can see what exactly our collision geometry is looking like. So let's go ahead and zoom in. So yeah, we're doing real work today, so we're not trying to be super entertaining. So if anybody has questions or anything else, you can always hit me up. But we're just trying to actually make some progress, document that progress for people who want to see what's going on and how the process, kind of how Adam and I are running things for the game. But these streams are not supposed to be tutorials on how to build everything, or just shop talk while we're doing our jobs, you know, that sort of stuff. So we'll zoom in here, and that'll make it so we can actually see what we're looking at. We turn on the trace tags, it's actually going to show us the geometry that this thing has gotten. I think basically what's here is we're going to need to apply a matrix transform to these world position and world extents. I don't think it's going to be absolutely correct. We need another transform here, because this is just like the world position if it was at nothing. So I think we need to apply the transform of the parent. I mean, we are rotating the size and the position right here, so we might actually have it proper and all that. I just need to verify. Does not look correct. There it is. Alright, so yeah, that does look correct. I had the wrong trace tag on, which is why I was not seeing it. And you can see the basic outline there is colliding with all the things. So yeah, we have successfully fixed that math then. So we can go ahead and remove this stuff from the code. We don't need it. This one thing ticked off our list. So now we need to check out debugging getting stuck inside of other objects. So we're going to put those fat sacks back in the scene. A couple of them, and we're going to look and see exactly what's going on with them, because right now we shouldn't be getting stuck inside of each other, but we kind of are. So you know, we'll take a look at that and see exactly why that is. Throw some breakpoints around and all the things. So let's get some fat sacks added. And basically, I think it's these fat sack proxies that have the fat sack crappy AI on them. Yeah, so we just throw these guys in the scene. They don't have any visual representation of themselves right now, but that is inconsequential. So let's throw some of them down here. Not too incredibly many of them. Save our level, and then when we play, we should see these guys doing some basic stuff. They're not doing much. What we're trying to do is... I got my console open. It's like, why isn't this? We were getting stuck on these guys. Which, the collision is supposed to be pretty weird. Alright, yeah, so we've got it right there. This child object is still colliding with the world after a yaw transform. So that's 898 on set direction. Looks like we don't have things rebuilt properly. Okay, so when we're flipping our direction, we're getting stuck, is what it looks like. So why is that? Like, we shouldn't have... We should be moving these objects one after each other. So if we collide, then we need to change ourselves. Alright. So basically what happens when we switch directions is our parent object has been moved, rotated in the world. So let's see if we can reproduce this real quick. Alright, so it looks like we did. So let's write down a few things. So basically our direction changed. This is inside of this actor is Dashkin entity actor 0, so I believe that's us. Actually, no. This is one of the AI is stuck. Okay. So one of the AI is stuck. Let's see, what animation are we playing right now? Of course, I only have IDs for my animations. I don't have string names for them. That's just amazing. Maybe the flipbook component has it on there. Alright, so it's the walk idle, so he's walking. So he's walking, and his direction is left, so he turned from right to left. I'm gonna need another piece of paper. It really helps me to write stuff down when I'm working on math. So let's see. So if we're now facing left, so we switched from right to left. What are we overlapping? We're overlapping Dashkin Entity 5? Alright, so let's see. Our position is... set relative location and rotation. 0 vector. Local rotator. So that we supposedly we overlapped and then we switched around and we were still overlapping. So we set our actor transform. We tried to we switched our direction, so we went from right to left. Trying to reason like this really shouldn't be happening, like, because what we did was we went through all the components after we've rotated our object. Yeah, the roll is at the moment -90. -90 is facing left. Well, maybe this is something I need to do where instead of Alright, so maybe it has something to do with that if the yaw was not equal to 0, that we have an issue? No, it doesn't always happen. Interesting. Why is this? I don't see them getting stuck. And you'd expect them to get stuck if this was totally screwed up. Well, what I should definitely do here is I should check if we're already colliding with something. So it's I believe a check if stuck. So basically, if we're already stuck, and of course this is going to be a whole hell of a lot harder to debug now that basically we've got a whole bunch of little fat sacks running around. Alright, so we're already stuck on trying to change directions. We're going to need a lot more information than this. Yeah, so basically what we're going to do is we're going to throw a GUID in here real quick. So we're going to know which one of these. Like if we've got this check if stuck, and then we're going to have to throw like a, this will all be an info log. We don't want to affect performance with it. We need to just trace stuff out. So the reason we have the GUID is we know exactly which ones of these info logs go together. Because we can't do it just with frames because we've got tons of little dudes running around. So we're going to have to, this is going to be, we are resetting a component back to the way it should be. So it seems like basically what I should be doing is, maybe there's an issue with the rotator. And basically I should be doing like, if there is any yaw, pitch, or roll, yaw, pitch, roll. And what we need is, basically we want a new rotator, so an F rotator. Let's just do origin. And origin is just going to be that, and it's flip.yaw equals 180. So basically when we change our directions, we need to figure out if we can also flip our child physics objects. And if we can't, we won't. Because we're trying to prevent things from getting stuck inside of each other. So basically, it's going to be like, we want to set this to if I guess we could just say like if origin does not equal Then we try to set it to origin. Can we not? Yeah, spell things properly, that would help. Otherwise we try to flip it. Yeah, so we try to set it to the way it should be, and the way it should be is basically that we don't have an extra transform. And if it overlaps, then we're basically going to flip it around the other way. And if it still collides, then we kind of have a problem because it should not have already been colliding. So that's why we're doing check if stuck up here. And if it's stuck to begin with before we change the parent, then we have a different problem altogether, is that our objects are actually already penetrating each other, and we need to fix that. Yeah, this has got to be the most engaging content of all time. We're just screwing around with penetrating objects. It sounds more interesting than it really is. Alright, so pop open our logs, hit play, and we'll see what happens. Okay, so it sounds like we also need to remove the debugging for our fat sack movement. Just because. So we can go figure out what exactly is going on with all the things. Gosh, it's Monday, isn't it? It's like an actual work day for normal people. And then of course it's Tuesday already for Adam, because Australia is the magical land of a day in the future. At least it is to me. So resetting a component back to the way it should be, and it's colliding with the world after the yaw transform. Why are we resetting a component back to how it should be? Maybe this is a smaller issue. I'm gonna remove the fat sacks from the scene because we don't need them. It looks like maybe, yeah, like it's like I am resetting myself back to the wrong things. So let's see why we're resetting ourselves. So the local rotator is saying 0000, and the origin is, I guess maybe the equals operator is screwed up with this thing. Number two, C++, where do you think you should start? Well, welcome, BuzzLink. I'm actually primarily a Java dev as well. At least I've been doing Java servers for companies for the past like 8 years, and also running like the game servers, which are all in C++ and everything else. So maybe we have things in common. So you're saying you want to get into C++ for hobby game building. Eventually, like to dev C++. Where should you start? It's a good question. I would ask, what interests you in game development? I'm just trying to figure out exactly what is going on with a few of these things. Local rotator.yaw equals yaw. We're just gonna set it back. Okay, we'll throw another basic check in here. Just a debugging thing. Doesn't look like check if stuck is ever returning true, which is good. 10 minutes for me in Java takes an hour in C++. I don't know the syntax. Basic inheritance. It gets annoying. Yeah, Java's real nice in that, when you're developing it, it just compiles, all the time. Like if you're in Eclipse or IntelliJ or whatever you're using, it compiles super quick. You can just do all sorts of crazy stuff. And once you get your Java framework set up, you can just be like, oh, I need to open this file and do all this crazy stuff. And then C++ is basically, you got to do all that crap all over again, and you're dealing with trying to fix components. You're like, oh, I need to open a file.